Okay, so today's video is called Converting Between Equations and Graphs for Trigonometric Equations Functions. So first examples, we'll start with an equation, build its graph. And the next example, we'll start with a graph and build its equation. We've already done this in class, but here's a good example for the videos. So, graph the following function and find its period, maximum, amplitude, and phase shift. So in order to graph this effectively, I think it's probably the best thing for us to do would be to go ahead and find period, maximum, amplitude, and phase shift to start. Okay, so for the period is equal to t, which is equal to 2 pi over k. And so if I look at my equation, my k value is 2, and so therefore the period must be 2 pi over 2, or just pi. And so the period is pi. I'll go with the amplitude next. The amplitude is written right there in the equation. First number, it is 3. The phase shift is also written in the number, or in the equation, and it is a negative pi over 2. Right here. Now to find the maximum, remember that the maximum, the equation that I gave you guys in class, was vertical shift plus the amplitude, vertical shift plus the amplitude, and in this case the vertical shift is 1/2, and so I will do 1/2 plus the amplitude, which I just found, of 3, or 3.5. Okay, so now given this function, I'm gonna go ahead and draw an axis here, and I'm going to make it a little taller than normal. I'm going to label this as 0.5. So labeling your axes is important. Okay, so this being a 0.5, because my vertical shift is 0.5, and then knowing that my amplitude is 3, I know that it's going to end up going all the way up to 3.5, and then it's going to go all the way down to 2.5. That's going to be the maximum, the minimum, and the 0 position. Then I know that my phase shift is a pi over 2, which means, because it's a cosine and it starts at pi over 2, then the first maximum is going to be right there at pi over 2. Okay, that was having to do with the phase shift equations, which I made a small video on that. So remember that a phase shift pushes the graph over in this direction this much. And since we're starting with a cosine graph, and usually it's first, the maximum is at 0, so therefore it must be at pi over 2. Okay, now the period. Remember that the period was pi. Over here, the period is pi. And so what I'm going to do is I'm going to add pi to this. Pi over 2 plus pi is basically is 3 pi over 2, or basically pi over 2 plus pi. And then I know that the full range of the graph, I should get back to a maximum again, because that's the nature of a period. So I'll definitely get back to a maximum again here. Then I know that right in the middle here is where I'd have my minimum. And it would be down at my minimum and right between the two maximums. And now the rest I can just kind of fill in here. And so I can just sort of do the best I can here by filling in the graph like so. Alright, and you only really need to fill in one period, and that would be a basic graph. And then we know that it would definitely continue on in both directions like that. Alright, and so that's basically the gist of it. That's a pretty solid graph. If everybody produced a graph like this, it would be pretty nice. One thing, I made a small error when I wrote down my question. This should be f of theta, because my variable is theta. And so then what I want to do is I want to label my axes and call this the theta axis, and call this the f of theta axis. Alright, so there is a graph of the function. The period is given or figured out, the amplitude is figured out, the phase shift is figured out, and the maximum is figured out. Alright, move on to now converting from a graph and making the equation. Okay. So determine an equation from the following graph. So by finding the period, the amplitude, the vertical shift, and the phase shift. So when going in this direction, it's not a bad idea to find the amplitude, the k value. I'll make that a lowercase a. So the a value, the k value, the d value, and the c value. Okay. And so let's make a graph here. I'll try and label it pretty well. Let's go with 1, 3, 4, pi over 2, 3 pi over 4, and pi. And let me put a couple of things on here. Well, let me go like this here. Then I'll go with trying to make one with a phase shift here. Sorry, I should have made this beforehand. Okay, so let's go with let's go with that one here. Okay, so this is a pretty good graph that we should be able to figure out. Okay, so what I'm going to do with this is I'm going to, well, let me write my A, K, D, and C a little bit closer here. All right, so the idea that we want to do is we want to start out by filling in some of the basic information here. I can see that my amplitude is going to be, this is a -3. Remember that the amplitude can be found out by doing maximum minus minimum divided by 2. So it's pretty clear that my maximum is 1 and my minimum is -3. So let's do 1 minus a -3 divided by 2, or 4 divided by 2, or 2. So that's my amplitude. Okay, and then this is pi over 4 here. So notice that was pretty easy to figure out. Now my period here. My period seems to be pi, right? And so the k value and the period are related. We can't just write pi in for the k value. We have to figure out what the k value is going to be. And so remember, for the equation, period is equal to 2 pi over k. And so what I'm going to do is plug in a pi for period and then solve for it. So pi is equal to 2 pi over k, cross multiply, or take these two and switch them. These two here, I can say the k is equal to 2 pi over pi. Cancel those out, and I get the k is equal to 2. Alright, so we'll just write in a 2 there. Okay, now D is the phase shift right here. Remember, this is the amplitude, this is the phase shift, this is the vertical shift, and this isn't the period, but it has to do with the period here, so I won't write period right there. Okay, now the phase shift, remember, is if I choose to use cosine, using cosine, the D value is equal to, it's basically the distance between the first maximum, this is the phase shift, the phase shift is the distance between the first maximum and the y-axis, so 3 pi over 4. That is my phase shift. I could use sine as well, but then I'd have to use the distance between the first, and it's not an easy thing to do. Excuse me. So the best thing to do when determining an equation is to use always cosine, and then just figure out the distance between the first maximum and the y-axis, because the maximums are always very easy to see, generally speaking. Okay, now for the vertical shift. Remember that the the maximum is equal to the amplitude plus the vertical shift. So for the vertical shift, I'm going to use an equation. It's equal to the maximum plus the amplitude. Sorry, let me change that. That's actually not true. It is the vertical shift. The maximum is equal to the vertical shift plus the amplitude. And so notice I know that the amplitude is 2. And I notice that the maximum is 1. I can write 1 is equal to the vertical shift plus 2, and now I can solve for the vertical shift by subtracting 2 from that side and that side, and I get that the vertical shift is equal to a -1. And we know that the vertical shift is the c value, or -1. So now I have an a value, I have a k value, I have a d value, and a c value. And I can just place these values into my equation. So remember that I'm using cosine. So f of x, we'll call this x, is equal to I'm going to use cosine k x plus or minus the d value and plus or minus the c value. And so I just take all of my letters and numbers and put them in here. And so my function, my graph, is 2 cosine 2x minus 3 pi over 4 minus 1. Okay, this is probably one of the most efficient ways to convert from a graph to an equation. Let's just go ahead and start looking at the maximums and minimums to get your amplitude. Try and look at the period to get your k value. To get your phase shift, look at the distance between the y-axis and the first maximum, and then always use the cosine. And then for the vertical shift, go with this equation. The maximum is equal to the vertical shift minus the amplitude. Plug in the amplitude, plug in the maximum, solve for vertical shift, and you end up with a nice equation. There are several other versions of this equation. Some that might not have this vertical shift, some that might use sine, but in the end, this is correct. This is a good equation. The book might choose a different equation though. Okay, so that's the gist of both of those topics: converting an equation to a graph and a graph to an equation.